Today we're going to be reviewing a couple of key ideas about cladograms and going over how to read a cladogram and how to determine possible evolutionary relationships from them. So we're going to start with just what a cladogram is. And so a cladogram, it's kind of just a graphic organizer. And it is a graphic organizer that is able to show us potential evolutionary histories. So how different species of animals are related to each other, potentially. It is not definitive because it's arranged by what we can see. So if you notice in this cladogram below, I'm going to erase this really quickly so we can read all of our species up at the top. We have a total of 7 different species. Okay. Each of those species has a branch that goes back to the main line of the cladogram. Okay, so the main line is going to be that really long line that kind of connects everything together. And then the branches, you get at least 1 branch per species. Sometimes, you saw examples yesterday, you can have species that branch off of the branches. And then it kind of just looks like a tree. But this one that we're looking at first, it is a simple cladogram. So for each branch, we have 1 species. Okay, and there's something really important about how all those branches fit together. It's what they show us. So if we look, let's focus on our mouse and our chimp. If we take the branch of the mouse and we follow it back to the main line, we take, the chimp's kind of on the main line, but we follow that main line back, we end up at an intersection point. Okay? You might remember yesterday they called that intersection point the node. We are going to label it something a little different. You don't need to remember node necessarily, but I do want you to be able to identify that that intersection point is where these 2 species shared a common ancestor. Okay, so that common ancestor is responsible for both lines. So somewhere before that common ancestor would have acquired the traits of fur and mammary glands. So this common ancestor having those traits is the reason that our mice have hair, our chimps have hair, and that they can both feed their young with milk. Okay? But there's a caveat to that. We do not always know how old that is. Why wouldn't we know how old that is? Well, think back to what you learned about fossils. There have to be lots of circumstances that line up just right in order for a fossil to form. So depending on how long this common ancestor lived on the earth or where it lived on the earth, it might not have preserved fossils. And so we can't always really identify what that common ancestor was. We can guess as to what traits it would have had, but we can't always identify what that common ancestor looked like or even when it existed. So there's kind of a big question mark that's attached to that. And it's a reason that this is just a representation of possible evolutionary histories, and it's not definitive. Because if we can't find that common ancestor, it's kind of just a hypothesis that this is how these species are related. Okay, but that exists on this cladogram. Each of these nodes is where we think a common ancestor would have been located. Okay, the other important thing that we can get from these cladograms, and it's how we make these cladograms, is looking at our shared traits. So just like we said, our mouse and our chimp share the traits of fur and mammary glands. Well, so too do our lizards, our pigeons, our mice, and our chimps share having claws or nails. And then all 4 of those, plus our salamander, share the trait of lungs. And so on as you go all the way down to our last trait, in which our perch, salamander, lizard, pigeon, mouse, and chimp all share jaws. Okay? But look over here. We have a hagfish who falls to this side, to the left side, of our trait of jaws. That means that this common ancestor between all of these guys up here and our hagfish, he did not have jaws. And so this hagfish did not develop jaws because there's no trait here that says jaws. If there was, then he would have developed it independently. But since that's not the case, we can draw the conclusion from this cladogram that our hagfish does not share any of these traits that the other species represented on it do. Okay, so I'm going to go ahead and erase that again. And we're going to move on to a different example up here. Let me zoom out and get that in focus. Okay, so just like before, every cladogram is going to have that main line, and then it's going to have the branches coming off to the side. So you can see here that these traits are still represented with hash signs on the main line, okay? And they chose on this one, you'll notice that in our first one, our pigeon, or birds in general, they had a trait here marked feathers, okay? This cladogram does not. It could have feathers marked here, right? But they chose not to represent that. And so that's a good reminder that this is just a representation, it's a hypothesis as to how evolutionary relationships are, but it doesn't always show everything, nor do we always know all of the traits that should be represented on it. So it's just a way of showing different species and understanding them in a graphical way, if you like to think like that. Okay. When I talk about evolution, when someone talks about evolution, a lot of times people get a picture that does not look like this in their head. Okay? They get something that looks like this in their head. Okay? Which is fine. You see that picture a lot. It's easy to think of it. But just because you see it, just because it's on the internet, does not mean that that's an accurate representation of evolution or an accurate representation of the evolution of humans. This animal, this species that we have represented at the beginning, is a chimpanzee. I'm going to abbreviate it chimp. Okay? And the way that this picture makes it looks like they're all walking forward, they're evolving forward, and this chimp is turning by the end of this picture into a human. Which is interesting. Because the evolution of humans, as shown in cladograms, does not show that. Okay? And that's one of the main takeaways I want you to have from class today, is that chimps did not evolve into humans. Okay, let's look at what a more accurate representation using something like a cladogram would be. All right, so here we have a tree of life, and you'll notice there's a main line that runs all the way through the middle here, and there are branches that come off to either side. Okay, so this is a very detailed cladogram. And it's a little bit hard to see, but for each of these branches, they have different characteristics as they go. So it's just like the cladograms that we looked at. I'm going to go all the way up my tree of life, and I'm going to zoom in. It's going to be a little bit grainy, so bear with me. Okay? You're going to notice that over here, we have a branch, and off of that branch, we have chimps. And then our main line, our other branch, continues this way, and that is the line that eventually leads to humans. Okay? So from this, you can tell that our chimpanzees do not lead to humans, because our humans are not branching off of this chimpanzee line. Okay? The chimpanzee line is branching right here, which means what? Well, remember, any place you have an intersection, any place you have a node, right? What does that stand for? That stands for our common ancestor. So anytime you have the intersection of two lines on a cladogram, that is a common ancestor. That means that at one point in time, chimpanzees and humans, there was a common ancestor. Was that ancestor a chimpanzee? Absolutely not. Chimpanzee was a species that evolved from that common ancestor just like humans did. But it is completely inaccurate. I'm going to go back to this first picture again. This is very misleading in saying that somehow chimpanzees led to humans. And hopefully that makes sense after looking at the tree of life, after looking at that other cladogram. All right, let's move on. Go ahead and pull out your worksheet that looks like this, your cladogram practice problems. And we're going to practice looking at a cladogram and analyzing it. Okay, so number one asks you what trait separates lampreys from tuna on this cladogram. Okay, so our first step is finding those two species. Look at your cladogram along the top where your species are, and you're going to find lamprey and tuna fish. Okay, we're going to follow those branches down, and you'll notice that the trait that is separating them is right here on our main line. That would be jaws. So that means that our tuna fish have jaws, our lampreys do not. Pretty straightforward. All right, let's look at number two. Very similar question. It's asking us what separates a salamander from a turtle. So I start with finding my species. Salamander is right here. Turtle is right here. Go ahead and look at your table. See if you can figure out that trait that separates the salamander from the turtle. Okay, so just like number one, we're going to follow our branches down, follow them down to the main line, and then we look at the main line, and the trait that separates them is our amniotic egg. So that is going to be the trait that that cladogram shows, is making a salamander different than a turtle. Okay, and maybe you don't know what an amniotic egg is. Maybe you think you don't. You all do. Go ahead and imagine an egg white. Okay, chickens have amniotic eggs. The amniotic fluid, that's just kind of what helps the yolk, which eventually evolves into, or eventually grows into the embryo and eventually becomes that baby animal. Okay, the amniotic fluid is just kind of the white part around it. So you all know what that is now. Then let's go ahead and look at number three. It's asking us which organism is most related to the leopard. So if I look up here at my leopard, okay, the leopard is kind of branching off of, it's kind of part of the main line. So I would go back through my main line. That leopard has hair, it has an amniotic egg, has 4 walking legs, it has jaws, and it has a vertebral column. Okay, so then I'm going to change my color here for a second, and we're going to look at the next organism. I'm going to focus my attention on the turtle. What traits does the turtle have? Well, I followed the line down, and he has an amniotic egg, he has 4 walking legs, jaws, and a vertebral column. He does not have hair. Okay, so he shares 1, 2, 3, 4 traits with the leopard. Change my color one more time. Let's look at the salamander. I'm going to follow his branch down to the main line. The salamander does not have hair. He does not have an amniotic egg, but he does have 4 walking legs, jaws, and a vertebral column. So he shares 3 traits. Now, if you would like, you can go through and calculate the rest of these. You would find that the tuna fish shares 2 traits. The lamprey shares 1 trait, and the lancelot doesn't share any. So our answer for this question, the organism that's most related is going to share the most traits. And you can tell from what we looked at that that is going to be the turtle. All right. So then the next question, we've figured that out already. The 4 traits that these organisms shared, those are the amniotic egg, the 4 walking legs, the jaws, and the vertebral column. Okay, so you can go ahead and write that down. I'm going to skip to number 5. Now, that one is asking us to figure out the organism that has the DNA most similar to the turtle. Okay, this one is a little bit tricky. So I'm going to circle our turtle in black to pay attention to him. And I'm going to change my color here. You might be tempted to say it could be the leopard or the salamander, because they're both one spot away from the turtle. Okay, but we need to do something similar to number 3. We need to figure out how many traits each of these organisms shares. So let's start with our leopard. Okay, the leopard and turtle do not both have the trait of hair, but they do have amniotic egg, 4 walking legs, jaws, and a vertebral column. So the leopard and the turtle share 4 traits. Okay, let's turn our attention to the salamander. Follow it back down, it's branched down to the main line. It does not share hair. It does not share the amniotic egg. They both do have 4 walking legs. They both have jaws, and they have a vertebral column. So the salamander and turtle share 3 traits. So after we look at it like this, after we figure out how many traits they share, it's clear that the leopard is going to have the DNA that's most similar to the turtle. All right, and we're on to our last practice question. So this one is asking us which organism's DNA is going to differ most from the leopard. And this one is a pretty easy one. So anytime you're looking at most different, you're looking from least shared traits. Okay, so if my leopard has hair, amniotic eggs, 4 walking legs, jaws, and a vertebral column, he has all 5 of those traits. The only one that shares none of those is the lanceolate. Because if you follow his branch down, he's his common ancestors before anyone developed a vertebral column. So our answer for number 6 would be the lanceolate. All right, so I hope that those practice problems helped you understand and feel more confident about looking at cladograms. Your assignment today is going to be very similar to this. So you can go ahead and show your teacher these practice problems that are completed, and then she will give you your worksheet, and you can get started on that in class today. If you have any questions, please don't hesitate to send me a message on Google Classroom. I'd be happy to answer them. And good luck on your assignment.